Terrish.
Hi, Mac. I'm good. How are you?
Good. Can I put together your usual for you?
Yes, please.
Awesome.
Awesome. And you can put that on my tab, babe?
You got it.
Okay. Thank you, hon. You're the best.
All right. Thank you.
Thank
Have a
you.
good day.
Okay, bye. Morning.
Good morning.
So we have our meeting this morning. So we're going to do the update on the wagon project.
Okay.
Yes.
All right.
And the report on the street quad project. Street quad.
Okay.
Okay. The guys are going to let us know how it's going.
Well, we know it's due Tuesday before we go to the
Well,
Fed
yeah,
Check,
and that's
so
what I reminded them. So
hopefully they're on time with it.
yeah.
Great,
Okay, you can crack the
great.
whip if they're not.
All right.
You ready?
I'm ready.
Let's go.
Morning, everybody.
Morning.
How you doing?
Good.
Not bad.
We all ready for this?
Guess so.
All right. Probably the first thing we want to cover is the street quad. Process on that, we wanted to have that done by Tuesday before we go to the FabTech show. So basically want to know where we're at with that stuff. Can anybody give me an update?
Just getting stuff back from paint and ready to do some final assembly.
All right.
How's your
Jane-
diet?
I'm doing it.
I'm glad you're
Thank
eating
you.
it.
Thank you for
I
giving
got
me
that
a
just for
donut.
you. I hope you like it.
It's good.
Okay.
Great. Thank
All right.
you. Okay, let's talk about the trailer that we've been working on. I know that we've given you some instructions previously, and I think that from what I can see, it looks like you got some drawings for us. Can we pass those around, kind of get an idea where we're at?
Absolutely. Take a look. See, that's where we're at right now.
How much more work do you think you have as far as your basic stuff? Are you ready to get more input as far as fastening things?
Absolutely.
Okay.
Yeah. Yes.
Okay, it looks like it's coming along really, really well. I like that. Good deal.
All right, here we are in the shop. Ta-da! And we've been working on the street quad, so I'm going to check and see if some parts came in that we were looking for, and they did. Look how beautiful this is. I love it. Oh my gosh. They got the grill on, the headlights, all the components, and now we're just putting the pieces together. This looks so nice. Wow. So we're totally on target for our...
Yeah, it looks like they've done a really good job. I think they're right on schedule right now, and we're hoping to have her done by this evening.
Well, good, because we have to go to FabTech, and
Yep, be nice to know
That's
that this
our
is
goal.
behind us and we can focus on our next day.
the paint looks
They did a fantastic job.
amazing. I can't believe how
They did a
beautiful it looks.
fantastic job.
All right, so this whole bit's in two pieces. We're just going to take the front part, put it on, screw some things in. I'm sure that's what they're probably going to do. And looks like it's going to be ready to go. So stick the wheels on.
All right, looking good. Come on here. Okay, we're all good. Come down on the side. Make sure when they move away, you got that.
Okay.
Hold it like this and you like the blocks. All right. You got it. Thank you for your help. Hope you don't break a fingernail.
No fingernails to break, so I think we're good. I'm not scratching, I'm not scratching. It's like when I heard you touch it.
How's it looking, Troy?
Good. A lot better than I thought it was gonna.
I can put this one on, I think. Is no one there? No.
My hand.
Yeah.
This is the blooper scene?
This is the blooper scene. Okay, cool.
Got lug nuts? There you go. Hold
Yeah.
it.
Beautiful. Oh my gosh, I can't believe it's finally finished. Are you excited?
I'm very excited.
Ah.
This is one beautiful rig.
I love it.
I've got something for you.
You what?
I've got something.
Something for me? What?
For you.
What do you got?
I would appreciate it if you put the final touches on it
I'm so
to make one
excited.
finished street club.
Okay, here we go. Are you
Here
ready?
we go. Here we go.
Screw it in. And done,
All
ladies and
right,
gentlemen.
good job.
All right, now I get to drive out of here. I'll just get on.
in your dreams.
Can I get on? Okay, I'm just taking off. So, thanks guys. Thanks for all your help. And how do I start it? get started.
You gotta have a key.
That's true.
How about that?
I get the gas cap and I'm
You
key.
get the gas cap, but you don't get the key.
I get the key.
We had fun. Good
That
job.
was a good job.
Jess, you're supposed to be tight.
Come on, Jess, get in there.
All right, here we are at FabTech. I'm super excited. I'm here with Mark Hooper, who is the Vice President of Media and Exhibitions for FabTech.
Correct.
Now, Mark, when I go through these doors, what can I expect? What's going on inside?
FabTech is North America's largest exhibition for the forming and fabricating industry. You're going to see over 1,500 exhibiting companies.
1,500, wow.
1,500
Okay.
exhibiting companies. You're going to see over 30,000 attendees that are going to come and visit FabTech. And
From all over the country?
From all over the world.
From all over the
Really.
world,
Yep.
okay.
You are going to see at FabTech virtually every kind of technology for the forming and fabricating industry, from tube and pipe to finishing to stamping to forming and fabricating to welding.
Wow, so I'm gonna see robots moving and different things and cool
Yeah,
stuff.
Yo, no question. And robots with automation, that goes across all technologies, from forming and fabricating to welding to finishing. It's amazing stuff.
Do you think they'll let me make something in there?
Maybe you.
If I ask them, pretty please?
They might let you in there, absolutely.
Now tell me more about manufacturing. Like, where are we headed? What's been going on in the past? Like, what's some new technology that's out there right now?
The primary reason for an event like FabTech is to be able for the manufacturers to show new technology. That's why the attendees are coming to FabTech, to see what's new. At an event like this in Las Vegas, you will see something in the neighborhood of 500 new products on the show floor. And again, that's really why the attendees come to an event like a FabTech, is to see those new products.
Awesome. Now, I hear there's a good job market for people that have those talents and those skills to be able to come in and be welcomed with open arms and come and join this industry.
You know, with as much as the mainstream media talks about difficulty that the overall economy has had, manufacturing has really been out in front of that. If you talk to a majority of the people that are out on the show floor as attendees that are manufacturing parts, they will tell you that they are looking for people. The difficulty is actually finding the qualified people that they need to run the sophisticated equipment that's out here.
Right.
Yeah, there's not a question that manufacturers are looking to hire, but it has to be the right people.
Right people, definitely. Okay, awesome. Well, I'm really excited. So if you don't mind, I'm going to get my hustle on and see if I can build me something.
Have fun.
Okay, thanks.
Thank you. Thanks for coming.
Hi, I'm Terrish, and here we are at FabTech, the manufacturing mecca. Now, they're not open yet, so you don't see thousands of people on the floor yet, but trust me, it's going to happen. And I've been taking a sneak peek at some of the machines around here, and I just can't wait to get my hands on some of these gadgets and gizmos and kind of see what they can do. Do you mind?
By all means, please go ahead, and what we're going to do is simply hit the start button, and then you're going to step on the pedal,
Okay.
and I'll hold the part, and you can actually form up a part.
I can make a part myself?
You can make a part.
This is exciting.
All right,
Okay.
go ahead.
Okay, ready? Ooh. Their side.
And here's the last
And
part.
one
Okay.
more. Oh my
Made an
goodness.
integral part,
You
knitting
guys,
part.
I'm now a pro, expert.
You are a pro fabricator.
So this is a pretty nifty machine you have here, Al. Tell us more about its features and benefits. Like, what is it? What does it do?
Well, Mazak is a manufacturer of sheet metal manufacturing machine tools.
Okay.
We process a wide variety of metals, typically in the flat format. But the industries we service are aerospace, automotive, food service industries. We use lasers essentially to cut geometries in metal.
So you're cutting just with a laser.
That's
cutting
correct.
right through.
Yep, it's using
Awesome.
a laser beam at high power to actually pierce through the material and cut different geometries based on the customer's need.
Wow.
Al, can you tell us a little bit about the advantages of a laser over, say, a punch press, which have been used for years and years?
Exactly. One of the things that the laser really brings to the manufacturers is a flexible tool. When we looked at the industry maybe 15, 20 years ago, we used hard tooling to make these geometries, and that tooling was very inflexible and was rigid to that specific geometry. If the geometry changed just a little bit, there was a need to retool the entire punch press operation. In this case, we can change geometry on the fly in a matter of minutes and cut a different part at a moment's notice.
So laser's very flexible compared to...
Extremely flexible to a hard tooling process.
And how long would you say this type of technology has been around?
The laser has been in the industry now for over 15 years. It was developed more than 25 years ago, but it really just now has become an industrial machine tool in the last 15 years, where it's used every day in all manufacturing elements.
Okay, great. Now, I saw, Al, that you had another laser over here as well.
Correct.
My understanding is this is a CO2 laser, and the other laser, a fiber laser. Is that correct?
Yes, that is correct. We've had really an evolution going on in the last 5 years in our laser world. Originally, the first introduction of lasers into manufacturing were called CO2 lasers, and that laser beam was created with gas. We basically mix different gases together, and that creates a laser beam. And we excite that gas, and ultimately that's what we're using to cut with. But now there's a new generation of lasers called fiber lasers, and those lasers are actually powered not by gas, but actually by diode light. So we actually use something similar to a laser pointer, and that laser pointer, of course, is much more powerful, and we use many of them and combine them together to actually give off laser light. So fiber laser is essentially hundreds, if not thousands, of laser pointers.
So how does the laser, how many lasers are in this machine that are going to be working? Is it just one
There's
laser?
one really large one.
Okay.
Okay. So you know, the average person who owns a laser pointer that they purchase at their local office supply store is quite small,
Right.
and not very powerful. It can point to something, but it can't cut through metal. We have the equivalent of that on a large scale, almost the size of a car. So the laser itself that's cutting the metal is quite large.
And it knows where to go because you program everything beforehand and then it just knows where to go.
Correct.
Okay.
Basically what we do is we take that laser light and we transfer it through the machine tool by mirrors. So we actually, every time that laser beam has to turn and get over to the sheet metal, it's being processed through a beam of mirrors.
That's awesome.
Yeah.
What kind of thickness capacities does this particular laser have?
The industry has really progressed in that case. Just a few years ago, some of the maximum material thicknesses were only about a 1/2 inch steel. But today, most of our lasers can go all the way up to 1 inch steel cutting.
Wow, that's pretty impressive.
Yeah, it's really come along.
This machine here, my understanding is it's a 4 kilowatt.
That's correct. It's 4,000 watt laser power.
So there's 4,000 watts of electricity going in to create that laser beam.
The actual power rating is wattage. Okay, and that wattage is how much amplification of power, how bright the light is, if you will. That's really how we designate laser power. The voltage is tens of thousands of volts igniting the gas to create the laser beam. The beam itself, in a matter of joules of power, that creates wattage, and that's how we rate the wattage on the laser.
Sounds pretty complicated.
A little bit.
It does sound complicated.
Now,
I'm like,
what kind of skills does one need to program this machine? I mean, I'm looking at the control here. It looks pretty complex. Where does the whole process start? Does that start from a different computer and then come here, or how does that work?
It's a really interesting question. Our industry, we have maybe 3 or 4 key areas where we look in the trades as to what type of engineers we bring on board to ultimately build such a machine. We have electrical engineers, mechanical engineers, software engineers, and design engineers that actually create mock designs of where we want to go, what the machine is going to look like. And then we have engineers to create the software to drive the controls, design the controls, drive system engineers, those are more mechanical engineers, and of course electrical engineers do a lot of the laser-oriented type of work.
so they're all working together to make this.
They all come together, each has a part and a hand in the building of the machine.
Yeah, it sounds like there's a lot of high-tech type skills that are needed to really run this machine and get it programmed to the point where you can actually make parts with it.
Very much so.
Do you see a shortage out there for those types of skills,
Yeah,
or how do you
absolutely.
see the labor market in that skill set?
Yeah, over the past 10 to 15 years, we've really seen a decline in individuals coming out of the trades and really embracing our world of machine tools. So there's a lot of other exciting industries out there, but ours is machine tools, and we really found ourselves almost starving for high quality tradesmen that know how to work with tools, design software for controls, mechanical engineers, electrical engineers, and we've gotten to the point now as machine tool builders, many of us here have introduced trade programs where we bring apprentices into our companies right out of high school and actually start to train them ourselves out of necessity.
And now, how long have you been in the industry for?
25 years.
25 years. And so, what sparked your interest in?
I started with cars.
You did?
I came from a family of gearheads, and we were always wrenching cars, so I always had a really high mechanical aptitude, and I really enjoyed working with my hands. But I also knew, my father told me, electronics is coming, and that you really should start to learn more about electricity and the drive systems and control systems. So I went to a 2-year tech school.
Okay.
And I got a degree in electrical engineering. So I was able to use kind of hands-on as well as electrical knowledge, combine the two. And when I got out of college, I said, well, where does that converge? Where does electronics and mechanics come together? And that's machine tools. That's how I found myself here.
What do you think is the most exciting thing about your job?
Oh, it's really being a part of the manufacturing world and actually partnering with people like John Deere and Caterpillar and people that make products.
Cool. Yeah.
And I can look back at the first start of inception of designing a new product and working with a company, whether it's a Boeing or something like this, and then maybe 5 or 10 years later, seeing that product actually out in the marketplace and realizing that I was a part of the development of how that was going to be manufactured.
I'm here with Ben Terreblanche, who is the CEO and president of SigmaNest. Now tell me, I don't know much about SigmaNest, so tell me exactly what this is. What do you do for the manufacturing company?
Well, Sigma Tech is our company name, and SigmaNest is the product that we make.
Okay.
It's a software system that is designed to program cutting machines, but it programs them in a special way. It programs them in a way that saves waste, avoids waste. When you have a lot of different parts that you want to cut out of a piece of steel, for example, the software will figure out the best way to lay this out so that you have the least amount of waste.
Oh,
and then once it's figured out this pattern, then it also calculates the path, the shortest path and the quickest way to cut these parts out of that sheet of raw material. So it makes manufacturing just more efficient. It makes it quicker and it makes it more efficient.
Wow, so we've been checking out all these machines today, and now we're seeing kind of where it starts, is you're putting it into the computer, send it off to the machines, they make the product, and that's awesome.
Yeah, so the software is almost like the brain of the cutting machine. The machine has a lot of muscle and it can move fast, but the software is going to tell it how to do this in the most efficient way.
That's awesome. So about the manufacturing industry, now what do you see are people that are growing up and trying to figure out what they want to do in their life and more focused on their career path? Do you find that people are misinformed about the manufacturing industry, or that they're not educated enough to find out which jobs they want to get into? Or
I don't know, misinformed. They probably are. There are huge opportunities in the manufacturing industry for people to get into it. There are a lot of different cutting machines available. There is software like this, but the missing piece is skilled people who are interested in this and who are able to run this kind of technology.
And what kind of skills do they need for this type of technology?
This type of manufacturing is very mathematically oriented. It is physics oriented. So we use a lot of things like computational geometry and different kinds of mathematics, computer programming and things like that. And there's a big need in that. In those, I mean, we have a lot of vacancies, for example, at our company for this kind of skill. So those are the kinds of talents that we're looking for.
It's definitely ongoing education.
Yes.
So you get your degree in this type of career and you just keep evolving with the economy.
Yeah, but it's also mathematically oriented. This is definitely mathematically oriented.
Okay, well, great. Well, thank you so much for your information.
Did you want to have a look at
Yeah,
how the
I would
software
love
looks?
to. Yeah.
All right.
Okay, perfect.
Please come this way.
How you're explaining
Okay, so
it.
this is, here we have some parts that we want to cut out of a sheet of 1/2 inch mild steel. We have the quantity that we want for each of them. And let's say they are going to be welded together to form a piece of agricultural machinery.
Okay.
So what the software is now going to do is it's going to take these parts and it's going to put it onto a sheet of raw material for us. So what I do is I click here and I say, create this next. So now
Oh
the
my
mathematics
goodness.
is going to figure this out for us.
How many pieces you can put on one sheet of metal? That's awesome.
And so the systems work this out, and then I can still go in and say, well, maybe I can improve the situation a little bit, or maybe I want to move this part around. So I have full control of how I want this thing done.
So what inspired you to do this?
Well, it's really driven by the need in the industry.
Right.
Companies with such kind of cutting machines really needed to come up with a way, and prior to this, they were trying to figure this out manually.
Right. Well, thank you so much. It's very informative.
Absolutely. Thank you.
Thank you.